All right, for this problem, we're going to take a look at the convergence or divergence of summation n equals 2 to infinity 1 over natural log n squared. The square here is a red herring. The important thing that we see here is a logarithmic growth in the denominator, which is very, very slow. So the denominator blows up, but blows up slowly, which means that this fraction will go to zero, but will go to zero slowly. And so for that reason, our intuition, because of the natural logarithm, is to think that this will diverge. Again, natural. So because we're going to think this is going to diverge, let's compare this to the harmonic series. So we use the limit comparison test. Let's take a look at the limit as n goes to infinity of 1 over natural log n squared and compare that to 1 over n. And our intuition is that this ought to be something that establishes that the numerator is a series that goes to that diverges. Here I have a harmonic series, and my inclination is that this is going to be even larger than the value of the harmonic series. So we take the limit as n goes to infinity of n over natural log of n squared. Okay, from this point, there are two reasonable ways of proceeding. Let me continue the first way. Limit as n goes to infinity. Let's write this as n to the 1/2 over natural log n whole thing squared. Now, why do I write it that way? I do that because I have one of my basic limits that I have memorized is that the limit as n goes to infinity of natural log n over n to the a is equal to 0 if I have any kind of exponent that is positive. And so the reciprocal would mean that the reciprocal here would actually blow up. And so this is actually equal to infinity. Okay, that's one way of establishing this. A second way of establishing this is to use L'Hopital's rule. So here I see infinity over infinity. And so alternatively, I could write this as the limit as n goes to infinity. The derivative of the top with respect to n is 1. The derivative of the bottom is 2 times the natural log of n times the derivative of the inside. So the limit as n goes to infinity of n over 2 times the natural log of n. Now I can use L'Hopital's rule a second time because this again has the form infinity over infinity. And so I would get derivative of n is 1 over 2 times 1 over n, which is the limit as n goes to infinity of n over 2, which of course blows up as n gets large. So either by recognizing this as one of our common limits, or else using L'Hopital's rule, I can show that this limit is equal to infinity. So I've got this limit. The bottom is part of a divergent series. So since summation 1 over n diverges, because it's a harmonic series, or alternatively, a p series with p equals 1, we conclude that the original series, 1 over natural log n squared, also diverges by the limit comparison test. Okay. So the intuition here is to get started is recognizing that in this problem, natural log is a very, very slow growing function, which means that this fraction will indeed go to 0, but will go to 0 slowly, even more slowly than 1 over n goes to 0.